Hello and welcome to the Kelsey-Hayes Light Duty Truck Anti-Lock Brake Service Program. My name is Larry Adderley and I'm coming to you from the GM Tech Center in Warren, Michigan. Today's program is intended for truck brake technicians and it focuses on the most recent updates and changes made to Kelsey-Hayes Light Duty Truck Anti-Lock Brake Systems. In the next 60 minutes, we hope to provide you with service tips and information that you can immediately apply to fixing anti-lock systems. The program won't spend a great deal of time explaining theory. Instead, we hope to focus on information and tips that will cut to the heart of the topic and provide real-world solutions to the most frequently asked questions. The program is split into 4 basic parts. We'll begin by discussing the rear wheel anti-lock or RWAL system and the zero pressure rear wheel anti-lock or RWAL system. Later, we'll look at the specifics of servicing the 4-wheel anti-lock or 4-wall system. Next, we'll spend a little time with service procedures that are common to both RWAL and 4-wall systems. And then in the final minutes, we'll open up the phone lines so that you can ask specific questions about the RWAL, ZP-RWAL, and 4-wall systems. Before we get started with the program, let me mention some of the existing training courses available to help you better understand light-duty truck anti-lock systems. The original light-duty truck ABS course was called RWAL 4-wall 1988 through 1991 applications. This course has since been superseded and now cross-credits 2 more specific courses. If you have never taken this original course, you need to enroll in the following courses. The first course is called Kelsey-Hayes Rear Wheel Anti-Lock Brake System RWAL and explains not only the widely used RWAL system, but also explains RWAL variations such as zero pressure RWAL and vehicle control module RWAL. The second course is called Kelsey-Hayes 4-wheel anti-lock brake system 4-wall. This program details the procedures required to service 4-wall systems. In addition to the formal training courses, there's also a videotape that covers RWAL and 4-wall service entitled RWAL 4-wall Update, a systems approach to diagnosis. This program is available through Kent Moore and is identified by the part number that's listed on the screen. Throughout this program, you'll hear reference of using a bi-directional scan tool to help diagnose the light truck ABS systems. The term bi-directional scan tool refers to both the Tech 1 and to Tech Line diagnostic terminals. Both tools provide a communication link with the module that controls ABS operation. You'll also hear reference of the Data Link Connector, or DLC. As you may already know, as of 1993, the DLC is what used to be known as the Assembly Line Diagnostic Link, or ALDL, connector. The acronym DLC replaces ALDL as the correct name of this connector. Let's now get started by looking at the Kelsey-Hayes RWAL and ZP-RWAL ABS systems. Both the RWAL and ZP-RWAL systems provide only rear wheel anti-lock braking. Both systems are very similar, but there are a few differences.
The primary difference between the two systems is that the RWAL system only works with a disc drum combination, while the ZP-RWAL system only works with 4-wheel disc brakes. First of all, let's take a look at the basic electronics used with the RWAL and ZP-RWAL systems. The brain of both systems is a control module that receives input from 2 sources, the brake switch and the speed sensor. The brake switch lets the control module know when the brakes are applied, and the speed sensor provides a wheel speed signal that allows the control module to determine when one or both of the truck's rear wheels are locking up. Based on the signal from the brake switch and speed sensor, the control module determines whether or not ABS is required. If ABS braking is required, the module takes control of the truck's braking effort by energizing solenoids in the valve that adjust brake fluid pressure. A signal from the hydraulically controlled reset switch tells the control module when the specific hydraulic phases of ABS braking begin and end. It's important to realize that the control module receives diagnostic input from every one of these components. That is, if the control module detects an electrical impulse that's out of the ordinary, the module will set a diagnostic trouble code. Here now is a look at the RWAL and ZP-RWAL hydraulic circuits, beginning with the RWAL system. Outside of the ABS components, the truck's hydraulic circuit shouldn't present anything new. A master cylinder, a combination valve, front disc brakes, and rear drum brakes. Inside the RWAL control assembly, there's an isolation valve, a reset switch, a dump valve, and an accumulator. Look at the screen carefully, because now you're looking at the ZP RWAL system. It doesn't look that much different from the RWAL system just explained. Components that are different are highlighted. First of all, notice that ZP RWAL is used with four-wheel disc brakes. The 3500 HD is the only truck that uses four-wheel disc brakes, and that's the only truck that uses the ZP RWAL system. Because ZP RWAL is designed for use with disc brakes, the system requires a different accumulator than the RWAL system. The accumulator is different in two ways. First of all, it's larger than the RWAL accumulator. It's larger because disc brake calipers require larger volumes of fluid than the RWAL's rear wheel cylinders. The second way the accumulator is different is that during an ABS stop, the ZP RWAL system is capable of collapsing the accumulator spring to achieve 0 psi of brake fluid pressure. In fact, that's where ZP RWAL gets its name, zero pressure rear wheel anti-lock. With a disc brake assembly, the ability to achieve 0 psi during an ABS stop is important. Unlike drum brakes that must overcome the resisting force of brake shoe return springs, a disc brake caliper will apply with only minimal brake pressure. If the truck were to enter an ABS situation on a very slippery surface, the ZP RWAL system might need to momentarily achieve almost 0 psi residual brake pressure to prevent the caliper brakes from locking up.
Before we continue, let me briefly summarize a few things. First of all, the RWAL system is used on a wide variety of light-duty trucks equipped with rear drum brakes, while the ZP RWAL system is only used on the larger 3500 HD that's equipped with four-wheel disc brakes. Secondly, the primary hydraulic difference between the two systems is that the stored accumulator pressure in the RWAL system never drops brake fluid pressure below 60 psi during an ABS event. The ZP RWAL fluid may go to as low as 0 psi on an as-need basis. These pressure differences are necessary because RWAL works with drum brakes and ZP RWAL works with disc brake calipers. As you might imagine, these subtle operating differences translate into slight service differences between the RWAL and ZP RWAL systems. Here now is Greg St. Aubin, a program developer from the General Motors Service Technology Group, elaborates on some of these differences.
Looking at the systems, it's pretty obvious to you that the actual system components are not interchangeable between ZP RWAL and RWAL systems. But what you may not realize, though, is when servicing RWAL systems on different vehicle applications, these components are not interchangeable. It's important to remember that when dealing with an M van with an RWAL system, that control valve is not interchangeable with the control valve on an S truck, being that the system's components are specific to the brake system application. Now, as far as servicing the hydraulic systems themselves, most of the procedures are identical. For instance, the bleed procedure is identical when dealing with either a ZP system or an RWAL system. The bottom line to remember when replacing components on any of our systems is to refer to the appropriate service parts information manual to ensure that you have the proper component for the vehicle application. Aside from the obvious hydraulic component differences, there's a difference in the internal electronics of the ECU or the electronic control units. Interchanging these components will prevent proper operation of either one of the systems, so it's very important not to interchange the modules. Just remember that the RWAL system uses a black cap module and the ZP RWAL system uses a gray cap module.
Related to the difference in modules is perhaps one of the most important highlights concerning RWAL and ZP RWAL service. To clear RWAL diagnostic trouble codes, all you have to do is interrupt power to the control module. This has created a real concern. Service records indicate that many RWAL diagnostic trouble codes are being cleared without properly diagnosing the problem that triggered the trouble code in the first place. Here's how to handle RWAL and ZP RWAL diagnostic trouble codes.
Here first is a look at the procedure required to handle RWAL trouble codes. If the warning light is on because of a suspected diagnostic trouble code, Access the trouble code by either using a scan tool or by grounding terminal A to H at the DLC. In this example, the technician is using a Tech 1. If a trouble code is present, it's a good idea to record it on the repair order for future reference. The key to remember is that RWAL trouble codes are instantly erased anytime power to the RWAL control module is interrupted. If you fail to retrieve the code before power to the RWAL control module is interrupted, the warning light will go out, but the trouble code will be lost, and your search for the reason why the code was originally set will now be more time-consuming and difficult. Again, the key with the RWAL system is to access the trouble code, write it on the repair order, and begin diagnosing the condition that set the code. Clearing codes and turning the warning light off without finding the cause of the original trouble code is a sure way to wind up with a service comeback. Here's how to handle diagnostic trouble codes on a 3500 HD that's equipped with the ZP-RWAL system. The ZP-RWAL module does not have a volatile memory. What this means is that the ZP-RWAL diagnostic trouble codes remain in memory even when power to the control module is removed. The only way to erase ZP-RWAL trouble codes is to follow a grounding procedure through the DLC. The strategy behind this feature is to prevent accidental code clearing, to help ensure that the problem that triggered the code is corrected before releasing the truck, and to provide the manufacturer an opportunity to perform further diagnostics once a module is returned. ZP-RWAL diagnostic trouble codes can be accessed by either using a bi-directional scan tool or by grounding terminal A to H at the DLC, and then counting the number of warning light flashes. Once the diagnostic trouble code has been accessed and the cause of the code is properly repaired, you can then clear the code and turn out the warning light by following these steps. First of all, with the ignition switch off, remove the stop hazard fuse that powers the ZP-RWAL memory. Second, turn the ignition to the run position. Next, ground pin terminals A to H at the DLC for 2 seconds. Remove ground for 2 seconds. Ground again for 2 seconds. And finally, remove the ground. Turn the ignition back off and replace the fuse that powers the memory. If the problem that triggered the first trouble code was correctly repaired, the trouble code should be clear, the warning light turned off, and the truck ready to go. Before releasing the truck, it's always a good idea to ensure the quality of the repair by running a bi-directional scan tool system test followed by a road test.
As a follow-up to that information, I want to mention one point. You may be wondering if it's possible to clear RWAL and ZP-RWAL codes using a bi-directional scan tool, and in this case, it's not. The only RWAL variation that allows you to clear trouble codes using a scan tool is the Vehicle Control Module, or VCM RWAL system that's used in some ST series trucks. Over the past 12 months, we've seen a substantial drop in RWAL warranty repairs. At the same time, ZP-RWAL warranty repairs have been on the increase. Let's learn more about these issues from Greg St. Aubin and Scott Daly. Scott's an anti-lock release engineer from the North American Truck Platform Engineering Headquarters.
In general, service has been doing an excellent job out in the field on the RWAL system. There were 2 main reasons which we recognize the field was having problems with that we actually made changes to our system. The first reason is the code 4, which everybody is probably quite familiar with. It's the dump valve, the reset switch in the dump valve. That situation was being caused by water seeping into the coil pack. The changes that we made is very noticeable to the technician because now at the coil pack you'll see a blue tint at the wire out area, and that's the sealant to prevent water from seeping in. The second reason is we've gone to soft codes in our system. What that is in a nutshell is the light will not remain on as it did in the past. The customer may recognize at one time and then at the next ignition cycle it'll be off, therefore preventing him to even bring the vehicle in at all.
To better understand the benefits of soft codes, first look at how a hard code operates. With a hard code, a fault is detected by the system. The ABS system is disabled. A diagnostic trouble code is stored in memory. The warning light is turned on, and the light remains on until the code is cleared by the technician. With an ignition-latched soft code, everything starts out the same. A fault is detected, ABS is disabled, a code is stored, and a warning light goes on. The difference is that the warning light only stays on during the ignition cycle in which it was set. When the truck is turned off and then restarted, ABS is again enabled, and the warning light is turned off. Even though the warning light is out, a code remains stored in memory until cleared by a technician. If the fault persists during the new ignition cycle, the system will again disable the ABS and turn on a warning light. The third style of code is called a condition-latched soft code. This code begins in the same way as the first two. The difference here is that the warning light goes out and ABS braking is restored as soon as the fault goes away. If the problem is only temporary, the light will only turn on temporarily, and ABS will only be disabled temporarily. All condition-latched soft codes, no matter how brief they may persist, remain in memory until cleared by a technician. It's important to remember that when an ABS malfunction occurs in any of the various ABS systems, the control module will simply turn off the ABS system and the vehicle will operate with the standard base brake assembly.
The introduction of soft codes and improved sealant of RWAL pigtail wire outs are two reasons why RWAL repairs have decreased. Let's now take a look at a situation that seems to be causing an increase in ZP RWAL repairs. If you'll remember just a minute ago a clip that detailed the different procedures required to clear diagnostic trouble codes from the RWAL and ZP RWAL systems, well, it seems as though these differences may be causing some confusion out in the field. Listen now as Greg St. Aubin explains the situation in more detail.
Even though we've seen a dramatic reduction in RWAL warranty repairs, ZP RWAL warranty repairs seem to be on an increase. This is due to the fact that technicians are using the RWAL code clearing procedure on ZP RWAL systems. RWAL code clearing procedure requires you just to remove power to the module and codes will go away. The ZP system has a non-volatile memory which will not allow codes to clear when you remove power to the module. Technicians unable to make the brake light go out, the anti-lock light go out, or codes go away, are assuming that the module itself is defective and replacing it. Replacing the module without addressing the original cause or for the code to be set results in a returned vehicle to service.
And we certainly don't want service comebacks. The key to remember is that in order to clear ZP RWAL trouble codes, you need to follow the grounding procedure at the DLC that was detailed a little earlier. At this point, let's shift our focus from the RWAL and ZP RWAL systems and look at the Kelsey-Hayes four-wheel anti-lock brake system, better known as 4WAL.
As you may remember with the RWAL and ZP RWAL systems, the control module receives inputs from the brake switch and the vehicle speed sensor. Based on that information, the control module determines whether ABS is required. If it is, the module controls ABS braking by way of solenoids that adjust brake fluid pressure. The 4WAL reset switch has been removed from 4WAL systems as of February 1st, 1993. Unlike the RWAL system, the 4WAL system also uses an internal fluid pump motor and a relay to control the motor. As with the RWAL and ZP RWAL systems, the 4WAL module evaluates the consistency of feedback signals and will set a diagnostic trouble code if an abnormal signal exists. Shown now is the RWAL hydraulic circuit that you should be familiar with from earlier explanation. Watch carefully as the system dissolves into a 4WAL system. As with the RWAL and ZP RWAL systems, each channel of the 4WAL has an isolation valve. Earlier 4WAL systems included a reset switch. It's important to again note that the reset switch and all related trouble codes have been eliminated from the most recent 4WAL system. The 4-wall's PWM valve functions much like the dump valve used in the RWAL and ZP-RWAL systems. 4-wall utilizes a high-pressure accumulator that serves to store brake fluid under high pressure for brake reapplication during an anti-lock stop. An electric pump supplies the high-pressure accumulator with fluid, and a low-pressure accumulator stores fluid purged from the hydraulic circuit when the 4-wall system decreases brake pressure. One small but important item within the 4-wall system is the internal bleed screw. This bleed screw is a critical part of properly bleeding the 4-wall system.
We'll go into 4-wall bleeding procedures later in the program, but first I want to elaborate on the reset switch that's been removed from 4-wall systems produced after February of 1993. In the past, 4-wall reset switches were vulnerable to a resistive film buildup on the connections of the normally closed switch. The resistive film caused the switch to remain open and would trigger 4-wall trouble codes 61, 62, or 63. As you may already know, the only way to fix this condition is to replace the entire valve assembly. Although new trucks are not equipped with the reset switch, there are still a lot of older trucks that have the switch. So it's important to understand that failure of the reset switch in these older 4-wall systems does not present a safety issue.
If the reset switch fails, it will trigger a diagnostic trouble code, turn on the brake warning lights, and disable the ABS brake system. If the customer ignores the warning lights, the truck will provide normal brake system operation, but without the added benefit of the ABS capability. As with any warning light, the brake warning lights indicate a system malfunction that should be addressed in a timely manner. Another 4-wall change brought about in the 1993 model year is the switch from using 4 wheel speed sensors to using 3 wheel speed sensors. As you may know, the 4-sensor system devotes a wheel speed sensor to each wheel of the vehicle. The 3-sensor system combines the 2 rear sensors into one unit that's mounted on the transmission output shaft. Ensure proper parts selection by double-checking the number of wheel speed sensors used on the vehicle being serviced. From a performance standpoint, there's no difference between the two systems. From a service standpoint, the key issue to remember is that 3 and 4-sensor 4-wall components are not interchangeable.
The transition from 4-sensor systems to 3-sensor systems began with all 2-wheel drive trucks at the 1993 start of production. By November of 1992, all-wheel drives also were being equipped with the 3-sensor configuration. At this time, I want to clarify a sometimes confusing issue regarding ABS on trucks equipped with 4-wheel drive. Trucks with the RWAL system do not provide ABS braking when the truck is in 4-wheel drive. Trucks with the 4-wall system do provide anti-lock braking when the truck is in 4-wheel drive. Let's learn why this is the case.
Well, quite simply due to the fact that on a 4-wheel drive vehicle, the front tires are connected to the rear tires via the drive line and differential. RWAL, which only has anti-lock brake assist capabilities on the rear axle, would have no effect on front tires that were locked. 4-wall, on the other hand, has the ability to both monitor wheel speed and control braking to all 4 corners of the vehicle and is usable and applicable in 4-wheel drive.
When most technicians go about diagnosing the 4-wall ABS system, they usually take advantage of either the Tech 1 or of the Tech Line diagnostic terminals. These tools make 4-wall service convenient as they allow easy access to diagnostic trouble codes and also allow the technician to clear the codes. For some technicians, these bidirectional scan tools are somewhat new to the business of servicing brakes. After all, before the widespread popularity of ABS braking systems, there was little need for electronic interaction with a standard brake hydraulic system. Before reviewing Tech 1 usage, let's listen in as Scott Daly explains what can happen if the Tech 1 is used incorrectly.
The Tech 1 is a very important tool as far as I'm concerned for the technician out in the field and diagnosing this system. It gives a lot of information right at his fingertips. There are some peculiarities, though, that we need to be aware of in diagnosing these systems with the Tech 1. The first item is in a 3-sensor system versus a 4-sensor system. If you select a 4-sensor system and you're diagnosing a 3-sensor system, you'll actually have 0 mile per hour on one of the rear wheel speeds. The second item is to always, if you have a question about the information, make sure you verify it. There are situations I've seen where a code will come up that is not even in our system, that'll show on the Tech 1. The easy way to verify it is grounding A to H to check and see if that code actually exists in the system. The third item that is the most important item is no communications. If the technician utilizes the incorrect adapter, the incorrect card, or the wrong Tech 1, or even the wrong cord for the system, there may be a situation that he comes up with no communication. This, at times, I've seen in the field, actually causes the technician to change the system change the unit because there is no communication, and eventually find out that it is just his Tech 1 and the way he has it set up.
Here's a review of the Tech 1 parts that are used to diagnose ABS brake systems. First of all, there are 3 cartridges that communicate with the 4-wall system. The newest is the mass storage cartridge, and it became available with the start of the 1993 production year. If this cartridge is unavailable, there are 2 older cartridges that will also work. One is the 88 to 92 chassis cartridge, another is the RWAL 4-wall cartridge. Any of these 3 cartridges will effectively communicate with the 4-wall system. As far as cords are concerned, use the RWAL 4-wall adapter TA02659 along with the GM truck anti-lock brake cable TA00011, A or B. When using the adapter, it's important to remember to plug the loose wire into the back of the Tech 1 connector. One of the benefits of using a bi-directional scan tool is its ability to obtain a history of codes set within the 4-wall system. The code history list allows you to look into the vehicle's past and get a feel for recurring codes that might have an effect on the current problem that you're trying to solve. The history codes are also good at helping pinpoint intermittent problems. Another benefit of using a bi-directional scan tool with the 4-wall system is its ability to quickly and easily clear trouble codes. As part of the list of essential tools, all dealerships should have received a bi-directional scan tool and have it available for use.
At this point, let's shift from Tech 1 explanation and learn about 2 different noise complaints against the 4-wall system. These 2 complaints aren't really problems. As Scott Daly explains, they are matters of customer education rather than system concerns.
As you may or may not know, the 4-wall system performs a self-diagnostic check when the vehicle reaches 8 miles per hour. The check involves cycling the components within the brake pressure modulator valve, or BPMV assembly, so that the module can perform a self-diagnostic check. Some customers objected to the noise created by the self-diagnostic check of early 4-wall systems.
To reduce the noise, we went to a balanced rotor within the motor. That did reduce it some, but there were still some complaints from customer about the noise. At that time, the time that the motor ran was about a half a second. We've now started with February 1993, reduced that time that the motor is running down to a fraction of the second, and it is non-existent at this point. There is a rather large problem with that now, though, is the customers expect that noise at times and actually come back to the dealership and say they don't hear it anymore. There is no problem with the unit if they do not hear that. If there was an actual problem with the motor, a code would be set and the light would be turned on. The second noise that the ABS makes is actually during an ABS stop. Customers are complaining about that. That's a very important noise to give the customer feedback. We have got to tell our customers that they have exceeded the traction of the vehicle and the ABS system has actually taken over to optimize their braking.
Over the past few years, we've seen 3 different sets of instructions regarding 4-wall bleeding procedures. In a moment, we'll walk through the most recent version of the four-wall bleeding procedures. But first, here's a look at some animation that will help explain what's going on during the four-wall bleeding process.
Shown here is one of 3 four-wall hydraulic circuits. For ease of explanation, we've eliminated the 2 other circuits that are identical to this one. All the following explanation assumes that the master cylinder has already been bled. Earlier, we mentioned the importance of the four-wall's internal bleed screw. The first part of the animation will show what happens to the system when the internal bleed screw is left closed during the bleeding process. When the internal bleed screw is closed and the system is bled, air will only be removed from half the four-wall valve assembly. During normal brake application, this won't be a problem because the lower half of the valve assembly is closed off. But as soon as the vehicle enters an anti-lock situation, the air that was trapped in the lower half of the system will be injected into the upper half. This action will create an unacceptable pedal feel after ABS braking. Here's the proper bleeding procedure. First, notice that the internal bleed screw is open and the high-pressure accumulator bleed stem is depressed. Now, when fluid comes in from the master cylinder, it will pass into both sides of the valve assembly. To further purge the system with air, close the internal bleed screw, release the high-pressure accumulator bleed stem, and then cycle the system using a bidirectional scan tool. As you may know, this bleeding and cycling procedure should be repeated until all air is completely removed from the valve assembly and the lines leading to and including the wheel circuits. Here now is a look at the process on an actual truck. The first thing to do when bleeding the system is to make sure that the ignition is in the off position. Failure to leave the ignition turned off may set false diagnostic trouble codes. Next, open both internal brake bleed screws 1/4 to 1/2 a turn on each side of the brake pressure modulator valve. Install a J39177 combination valve pressure bleeding tool on both the left and right pressure accumulator bleed stems, as well as on the combination valve. Make sure the master cylinder fluid reservoir is topped off and check it regularly during the bleeding process. Next, using any method you prefer other than a gravity bleed, go ahead and bleed the brakes, starting with the right rear, left rear, right front, and finishing with the left front assembly. Once the system is bled, close the internal bleed screws and remove the combination valve pressure bleeding tools. Recheck the master cylinder fluid level and then turn the ignition to the run position, but don't start the truck. Using a bidirectional scan tool, perform 6 function checks, one right after another, and check the truck's pedal feel. Chances are you'll need to repeat the bleed procedure again before all of the air is removed. It's common and acceptable to use as much as 2 quarts of brake fluid during this bleed procedure. Here's a tip that might save you some time if you ever have to replace a four-wall brake pressure modulator valve. Replacement BPMVs come with their internal bleed screw in an open position. Once the BPMV is installed on the truck, always remember to close the valve before releasing the truck. If you have any questions about the procedures just covered, refer to any of the bulletins identified on the screen. Just a few final tips concerning the four-wall bleeding procedure. If you forget to retighten the internal bleed screws after the bleeding process, you'll probably have a spongy pedal. And if you're working on a system with the reset switch, you might also set codes 61, 62, or 63 as indicated by both warning lights.
It's very important to understand that you no longer can gravity bleed the system. That's number one. Number two is you have to make sure that the bottom portion or the pump portion of the BPMV is filled. Take the proper steps by using the Tech 1 to get the air out of that bottom portion. Number three, when you're all done, make sure that the pedal feels proper for the customer and it's not spongy by doing systems test with the Tech 1 and checking the pedal afterwards.
Before we leave brake bleeding entirely, let's listen to Greg St. Aubin as he elaborates on the reason why 4WAL has had 3 different brake bleeding procedures in the last few years.
Well, bleeding procedure has evolved over the last few years. It's important to remember that none of the bleed procedures have ever been bad. They all work. It's just as we've gotten better at doing our jobs, we've gotten a more effective and faster way of bleeding the system. The first system bleed procedure came out prior to the introduction of bi-directional scan tools such as the Tech 1 or TechLine diagnostic terminal. We simply bled the system utilizing the base system bleed procedures. Second system came around after the advent of the bi-directional scan tools, where we actually cycled the valves within the control units to help purge air out of the system. And finally, the newest and latest procedure is a result of finding that by opening the internal bleed screws, we're able to purge the bottom portion of the EHCU of unwanted air and make the system bleed out quite a bit easier.
Now it's time for you to join in. I'd like to invite you to call us toll-free by dialing 1-800-836-3551. This number will only remain active during the live telecast. Greg and Scott have joined me to answer any questions regarding material that we've gone over in this program, and in fact to answer whatever other questions you have regarding anti-lock brake service procedures. But first, let me take a moment to explain the test that's included with the telecast packet that was sent to your dealership. Test questions will not be read over the air. Instead, complete the test by filling in the computer answer sheet and mail the tests in the envelope that was included with your telecast packet. At this point, I'd like to welcome Greg and Scott to our program, and we'll be looking for questions from you if you'll dial us up on that 800 number. I've got one to begin with, however, Scott. Just this week, the field was informed about the Kelsey-Hayes Technical Assistance Program. Can you expand on that a little?
Sure. The object behind that is we've tried to get this program in effect about the same time the Delco. A lot of you may recognize that this program is going to be very similar to the Delco system, ABS 6. We have done this for several reasons. One, to get us quick feedback from the customers and the items that you're noticing out in the field, but also it gives us an opportunity to give you out there the latest of the pieces, the 4WAL units, so that you can correct the customer's problems right away. It also gives you an opportunity to call into a Kelsey-Hayes person, and he'll be able to give you any assistance and help you through that properly diagnosing, so we can get the customer satisfied the first time.
Can you do that long-distance diagnosing over the phone?
Yes, yes. I have done it on many occasions. They will also have the opportunity that they have the Kelsey-Hayes engineering as well as the truck and bus engineering to back them up, so that if there is some kind of problem that is very hard to diagnose, we'll be working with them, giving them back up to make sure that the problem gets corrected.
All right, our first caller is online from New Mexico. James, go ahead.
Yes, it's concerning the reset switch in the EHCU unit. Is that going to be a retrofit for past systems?
I'll take care of that one. We have done a lot of work in the last year to help take care of the reset switch. I think you'll even notice that in the 93 model year, warranty and the problems that you guys should be seeing out there has greatly reduced. But we didn't want to take any chances with it. So that's why in February we got rid of it. However, any of the units that are coming up that you're fixing older vehicles out in the field, we will have the latest of what's in there to make sure that that problem is taken care of for the customer.
Does that take care of your question, James? Good, thank you very much. Having the latest is important, Greg. For example, why were the diagnostic trouble trees removed from the updated RWAL and 4WAL systems?
We've been hearing that quite a bit out in the field. Why did you take the trouble trees out of the existing course room book? Service Technology Group, the entire focus of STG is to do whatever it takes to help the technician do his job properly. we found that we were duplicating efforts of the service manual people, plain and simple, by reproducing different type trouble trees in our books. So as a result, we found that if we use the service manual in class as a support aid for a classroom presentation, we get much better response from the technicians utilizing one set of trouble trees as opposed to two sets.
Updated information all the time.
Every year.
Another caller from Alabama. This is J.D. Go ahead, J.D. You're in there somewhere, J.D. Have we got him having trouble with our Alabama connection? I think you went. Maybe we answered his question. All right. As we saw on the truck new features telecast, 4-wall was introduced for the first time on the 93 model G van.
Hi, J.D. calling from Davis Chevrolet in Eufaula, Alabama.
Oh, okay. There you are, J.D. Go right ahead with your question.
I can't hear him.
You can't hear me. I can hear you. So you go ahead with your question. If somebody can tell them to go ahead.
The question is during four-wheel drive, is 4-wall disconnected, disabled?
I'll take that, J.D. In four-wheel drive, that's one of the greatest high points of our 4-wall system. Our 4-wall system is active in four-wheel drive. It does have control of all four corners of the vehicle, as we talked about earlier. RWAL, however, is disabled because it only controls the rear axle, so it would be ineffective in four-wheel drive. So 4-wall is active in four-wheel drive. RWAL is not.
J.D.?
Thank you so much.
Okay, J.D., just so you understand a little bit more on that, if you think about it, four-wheel drive, you're direct connected the fronts to the rears. Okay, so with rear wheel anti-lock, if the fronts lock up, you're going to lock up the rears. So it was very important. That's why we disconnected it for the RWAL system when you go into four-wheel drive. But just remember, just an easy way to remember that, since you're direct connected front to rear, since you're controlling both the fronts and the rears, we can go ahead and keep it active in four-wheel drive.
Thanks, J.D. Hope that answers your question. Off to Kansas now, and a question from Steve. Go ahead, please. Well?
Hello?
Go ahead, Steve.
Yes, I'd like to know, the 4-wall is quite expensive, and when some of these units get out of warranty, I wonder if they can be or are now possibly could be rebuilt or anything. Factory rebuilding.
Any plans for that?
Good question. We're working very hard with this phone call program that Kelsey-Hayes has. We're working very hard on getting a remanufacture program going on too to reduce the cost. So yes, that should be coming up very shortly. Probably one thing to remember with these remanufactured units too, as we talked about earlier in the program, that if you have a new unit that's dry, the bleed screws will already be open. I don't know if the decision has been made yet at this point with these parts that are remanufactured. They may be wet when you get them, and the bleed screws may be closed. So just kind of a thought, you might want to just look at opening those internal bleed screws, like we were saying, a quarter to half a turn.
Thank you, Steve. Appreciate your call. So rebuilds are on the way.
Yes.
Let me go back to the question I started a few moments ago. The new truck features telecast and the 4-wall first time was introduced in the 1993 model G van. Have you seen anything different with the G van application?
In general, the G van application is following pretty much the same setup as all the other vehicle lines. However, we have noticed one thing that we're really concerned about, that we're just onto it right now, and this might give you an idea how slow the feedback is to engineering, is the upfitter vans are experiencing a situation where you would see it as the ABS light is on and there's no communications to the diagnostic tool. What's causing this is somehow we're getting an electrical high current feed through our low current module, and it's damaging our module. So we're working feverishly right now to find what the problem is and correct that at this point.
That's a constant problem, both updating information and modifying the pieces too.
Exactly, as well as getting feedback to us so we can make the corrective actions as quickly as possible.
You hear that? Your feedback is important. That's why we're fishing for phone calls on our 1-800 number. Happy to hear what your questions are so that our experts will be better informed about their own equipment. Let me go on here. Greg, why has the one-day RWAL, 4-wall combined class been changed to a half-day for RWAL and a full day for 4-wall?
Well, we just finished up in the last month or so a very aggressive restructuring of all the anti-lock brake courses, not just Kelsey-Hayes, RWAL, and 4-wall. During the restructuring, we found that Oldsmobile technicians, plain and simple, don't need the RWAL training because they only have the bravado with 4-wall. So we chose to break out the RWAL course as a separate course, that being a half-day program, which has been pretty consistent with how it's presented in the RWAL 4-wall class. The 4-wall, on the other hand, is a very, very sophisticated system, and with the introduction of performance-based training and the different systems applications that we have, it only made a lot of sense to utilize a full day for 4-wall. Now, what we've got to remember, though, is if you've been to the old RWAL or 4-wall class, we're not asking you to come back for training. Those already cross-credit the new classes. Another thing I'd like to mention is through the training centers, we're very appreciative of the technicians. They have been flocking into the RWAL, 4-wall classes. They've really shown a lot of responsibility as far as knowing that they need the training and coming in and getting it.
And they're giving us a call, too. We're off to Texas now for a question from Jack. Go ahead, Jack.
Yeah, I'd like to know why the bleeding procedure in the shop manual does not incorporate using the Tech 1.
I guess I'll have to check on that one. The latest, you did get a service manual update that came out for 92, and also the 93 book should have it, but it's a good question, Jack. I'll take a look at it just to make sure. I'm pretty sure that it is in there to actually cycle the system because I feel that's very important. Again, we were saying to fill that bottom portion of the unit. And I could swear to you, I'm the one who kind of works on writing these things, and it should be in there. Is there any particular manual that it might be in that I can check on? If not, I'll just go ahead and check.
The older manuals.
Yeah, okay. The older manuals, you did get a service manual update that came through early in like September of '92. That did state all past model years was to use this procedure also. So use that as well as if you look in the 93 shop manuals, it has it in there.
Jack, if you'll give us your full name and your dealer code, we'll be able to send you the information you're looking for here.
Jack,
all right?
I'd also want to reference the bulletin, which we talked about earlier in the telecast. We gave you the bulletin numbers. That also includes the update, which is the actual service manual update.
So we're going to pull his number off camera backstage, or we're going to take it now? All right, Jack, go ahead. Your dealer code, please.
51286.
51286. And you are Jack?
White.
White. Okay. We'll get you the information then, Jack, as soon as we can.
Thank you.
Thank you for your call. We are off to North Dakota now for another question. David?
Yeah.
Go ahead.
What I'm wondering on a T-truck on the 4-wall system, when it's in 2-wheel drive, the front wheels pulse independently, right?
That's correct.
Okay, in 4-wheel drive, do they pulse independently or simultaneously for steering control?
Well, that's a real good question. You're getting a little bit into algorithm there. That's the reason why I've got an extra signal when we've got a 4-wheel drive vehicle for that. The system does change to a different algorithm. It works somewhat independently. It's always looking at each of the wheels individually, but since it knows it's in 4-wheel drive, the algorithm basically controls looking at all the wheels at the same time. But that's a very good question. We work off of a different algorithm when we're in 4-wheel drive in the software than when we're in 2-wheel drive.
That take care of it for you?
Yes, it did. Thank you.
You're welcome. Michigan, a caller. Is this a caller from Troy, or is this Troy from Michigan? Troy?
Troy.
Go ahead.
Yeah, we have a bi-directional scan tool that we've never been able to pull codes from it or get into any diagnostic information with it. and we have all the brake modules for it, and it just doesn't seem to do any good.
That a bad
Troy,
tool? Or?
Yeah, Troy, let's do this. Let's get your dealer code on that. There is an 800 number for the Tech 1 group. I don't have it directly right now.
I've got it here, Scott.
Okay.
The Tech 1 1-800 number is 828-6860. That's 828-6860.
Try giving them a call, see if they can assist you. Let us also take you got your dealer code here so we can write it down, and if you do run into problems, I'll check back with you and see if you did get it taken care of, please.
Yeah, it's 21047.
21047.
That's GMC.
Okay.
That's Dave?
Troy.
Troy.
Good, Troy. Thanks very much.
Thank you.
Off to Virginia now. Mark has a question. Mark, go ahead, please. Can you hear me, Mark? You go right ahead with your question. There's Mark. Mark's in there. No, Mark got disconnected. All right. What can we do, Greg, to help make sure the service manual reflects accurate diagnostic information?
Oh, that's a great question. We've had a lot of technicians complaining in the past about inaccurate service manual diagnostic information in the trouble trees. That's why they like the extra set of diagnostic trouble trees we included in the old RWAL 4-wall book. With including service manuals in the new courses, we found that technicians are giving us a tremendous amount of feedback on the service manual feedback forms. They're utilizing the system in place to feedback inaccuracies or lacking information to the service manual people. If technicians keep in mind that every correction that they find, if they feed that back to the appropriate staff using that feedback form, it's going to make a better product for all of us. Everybody benefits by better service manuals.
So it's possible, finding that information is critical, and keeping it up to date is even more important.
Very much so, yes.
Another question from Phil. Don't know where we're from, Phil, but go ahead. Oh, all right. No, we don't have a question from Phil. It's possible that Troy's equipment is malfunctioning. Is that why the bi-directional tool is not giving him
That's correct. From
kinds of codes?
From what Troy was saying, it does appear that he does recognize he has the correct connections. One thing he may want to check, and we'll get with him, is that he does have the proper card that goes into it. I have seen many cases where they will have the correct connections and everything. However, they'll have the ABS card, their analog card, which may be for a Buick or something like that. There is a mass storage
Confounding the tool.
Yes, there's a mass storage cartridge now that handles everything. So that allows one cartridge to be plugged in and allows them to handle everything. All they have to do is worry about the proper connections to the vehicle.
All right, to Louisiana. Tommy has a question. Tommy, go right ahead, please.
On the 4-wall system, we know that you're having a problem with the reset switches with corrosion.
Yes.
When a vehicle comes in and you know you have that problem, what is the proper procedure that you want the technician to take?
The proper procedure, it's been going round and round, that there have been occasions that you've been told to just clear the code and send the customer on his way. As far as I'm concerned, that's going to do no good for the customer. He's going to be back again. The best thing for you to do is call in now to this new Kelsey-Hayes line, tell them the code, it should be a 61, 2, or 3, and they will right away get a unit shipped out to you that will have the latest of everything, and that customer won't come back. I don't want the customer back again.
Neither do you, I imagine, Tommy. Does that take care of your question?
Yes, it did.
Tom, we're very frustrated with that code. We're doing what we can right now to clean this up. Your help is, that we can ask of you, is make sure you get on that Kelsey-Hayes line. Let's get you the latest unit and get it on that customer vehicle when they have a code like that.
All right. Staying in the South, but moving to Florida, a question from Dwayne. Go ahead, Dwayne. Thanks for calling.
Yeah, I have one question about bleeding your system. Now, a couple of technicians, what happened is they went to school and they said that they eliminate the bleeding screw. you know, they eliminate bleeding the internal bleed screw, all right, and they said you don't have to bleed the system that way anymore. Now, is this true? According to what you said before, you have to use those internal bleed screws.
Absolutely. If you go back at the beginning of this tape, it's one of the biggest concerns that I have is we've got to get that internal bleed screw open. And if you watch the tape again at the beginning of this, you'll see that you'll fill the top portion of the unit, you'll send the vehicle to the customer. First time he hits an ABS stop, that pedal's going to go down on him, and he's going to feel a bad situation. He's not going to be pleased with that pedal. So we need to get that corrected back to the service group. If you're talking about the STG, if you could tell us your location, I'd like Greg here to get with the fellow who's instructing that class and want to make sure that that gets corrected.
All right, Dwayne?
Thank you.
You're welcome. Thank you for calling. We're out of time. Let me thank all of you that phoned in questions. Feedback from the field, as we said earlier, is very important in helping us take corrective action. Don't forget to send your tests to CPT headquarters in the envelopes provided, and be sure to watch for our next telecast on the new S&T trucks coming in mid-July. Thanks again.